Hi, welcome to lesson 2 of arc sectors and angles and circles. Today we'll be looking at finding the length of an arc. Before we do that, I'd just like to point out that you might notice on the slides today in the top right hand corner there will be a pencil and paper icon at certain points. If you see this, can you copy the notes and examples into your notes jotter or complete the exercise into your class jotter? Okay, we're going to have a look at a lesson starter now. So we're just going to recap what we looked at in lesson 1, the circumference of the circle. You can pause the video for a minute or two and have a go at question 1 and 2 here. Okay, we'll look at the answers to your questions now. So from yesterday, you should remember that if you have a circle with diameter 19 metres, the circumference will be pi times the diameter, so that's pi times 19. And if you work that out on your calculator, you get 59.7 metres. For example B, we have a circle with a radius of 3.6 centimetres. If the radius is 3.6 centimetres, then the diameter is 7.2 centimetres. So the circumference will be pi times 7.2, which gives us an answer of 22.6 centimetres. Now we'll have a look at question 2, and it's just a little quick one. How many degrees are there in a circle? So we should all know that there are 360 degrees in a circle, otherwise known as a full turn or a complete turn, and also a rotation or a revolution. Okay, so today's lesson we are going to be looking at calculating the length of an arc. By the end of the lesson we should be able to identify an arc, know the arc length formula, and calculate the arc length with appropriate working and units. Okay, so what is an arc? An arc is actually part of the circumference, so we actually say it's a fraction of the circumference, and we can see that from the green curved line between A and B. Across from the arc is an angle X. We call this the angle at the centre. If the angle at the centre is less than 180 degrees, then a minor arc is produced. If the angle at the centre is greater than 180 degrees, then a major arc is produced. Okay, so now we're going to look at calculating the arc length. From the previous slide, we can see that the arc was a fraction of the circumference. If we think back to BODMAS, of equals times, so we can write this as the arc is a fraction times the circumference. And remember, circumference is pi times the diameter. So how do we get the fraction? Well, the fraction is obtained by putting the angle at the centre over 360 degrees, since there are 360 degrees in a circle. Let's look at an example. So example 1 here, we want to find the length of the minor arc XY in a circle with a radius of 6 centimetres and an angle at the centre of 45 degrees. So the arc is a fraction times the circumference. So arc XY, your fraction is 45 degrees over 360 degrees multiplied by the circumference, which is pi times 12. Now remember, the diameter is 12 because the radius was 6 centimetres. Then all we have to do is put this calculation into our calculator and we get 4.71 centimetres. When we put the calculation into the calculator, we need to remember to divide by 360 degrees because 360 degrees is on the denominator of the fraction. So let's look at a second example. We want to find the length of the arc AB in a circle with a radius of 9 centimetres and an angle at the centre of 60 degrees. We need to assume here that it's the minor arc we're looking for, since it's not stated in the question. So if it doesn't mention it in the question, it's always the minor arc you work out. Again, the radius here is 9 centimetres, so the diameter will be double that, so the diameter is 18 centimetres. We remember that arc is equal to the fraction times circumference. So your arc AB is equal to your fraction, which is 60 degrees over 360 degrees, multiplied by your circumference, which is pi times the diameter of 18. Again, if we put this into the calculator, we would do 60 divided by 360 times pi times 18, and that will give us an answer of 9.42 centimetres for the length of the arc. So we're going to look at a third and final example, and this time we are wanting to find the length of the major arc AB. But to be able to find the major arc, we need to use the major angle at the centre. So we have to do 360 degrees, take away the minor angle of 72 degrees, and that gives us an angle of 288 degrees as the major angle at the centre. Our formula for arc length is arc is equal to a fraction times the circumference. So the major arc AB is equal to our fraction, which is 288 over 360 degrees, multiplied by the circumference. But we need to remember that because the radius is 13 centimetres, the diameter is double this, so it's 26 centimetres. So the circumference is pi times 26. We put this calculation into our calculator. 288 divided by 360 times pi times 26, and that gives us a final answer of 65.3 centimetres for the length of the major arc. Now it's your turn to have a go. Complete the following questions in your class jotter. Remember, you can pause and take as long as you need on each question. Remember also to show all appropriate working. So that should be your formula, sum, and answer with the correct units. And lastly, remember, if you do not have a pi button on your calculator, you can use 3.14, but your answers will be slightly different when you check and correct your work at the end of the exercise. So now it's over to you. Good luck.